Let's review some goodness of fit hypothesis testing problems. Question 1. A restaurant owner has given out 140 free coupons to special customers that will all be used. Of interest is whether the customers have a preference on the day of the week. Fill in the expected frequencies in the table below. Recall the formula for expected frequency is equivalent to n times p, where n is the sample size and p is the probability. In this problem, we know the sample size is 140 individuals, so n equals 140. Now, what is the probability? Well, let's assume that the days of the week are equal likely to be selected, and there's 7 days of the week. What is the probability of a day being chosen? Well, that's 1 out of 7. So to calculate the expected frequency, we are going to take the sample size, which is 140, and multiply that by 1 over 7, and this will give us 20. So if we're assuming that each day of the week is equally likely, then we can expect about 20 people will choose each day of the week. And that's kind of the introduction to our null hypothesis, the statement of no difference. For the null hypothesis, we'll assume there is no preference, and so each day of the week is going to have an expected count of 20 each. Question 2. A random sample of 1,860 Texas government employees were selected for a study on race. The table below shows the results of the survey. The racial distribution of the state of Texas is shown in the second column below. Fill in the expected frequencies, round to the nearest whole number. Again, we'll rely on our formula. The expected frequency is equal to n times p. Here we have n is equal to 1,860. And if you were to double check, the total of all of these individuals should be 1,860. Now the p is the percentage. The percentage differs depending on the race. So for the first row, we're going to take n, which is 1,860, and multiply it by 40%. 40% is 0.40 as a decimal. And this should give you 744. So out of 1,860, 40% of those individuals would be white. So we expect 744 individuals to have this race. For the second row, it's very similar. We'll take 1,860 and multiply it by 40%, or 0.40. And this should give us the same number, 744. For the third row, we'll take the sample size, 1,860, and multiply it by 10%, or 0.10, and this gives us 186. So we expect 10% of the population to be black. Now for the last part, we have 1,860. Again, the other is 10%, so we'll multiply by 0.10. This gives us the exact same number, 186 individuals of other race. Question 3. Are phone calls equally likely to occur any day of the week? The day of the week for each of 476 randomly selected phone calls was observed. The results are displayed in the table below. Use alpha equals 0.05 significance level. Part A, complete the rest of the table by filling in the expected frequencies. The frequencies of phone calls for each day is given below. We'll use the formula. Expected frequency is equal to n times p. N is our sample size. In this question, we have the sample size is 476, and the probability is 1 over 7. Where did we get 1 over 7? Well, there's 7 days of the week, and we're assuming that it's equally likely. So we have a 1 in 7 chance of picking a day of the week. We have 476 times 1 over 7, and that will give us the expected frequency for each of these entries. And that is equal to 68, so we know there is 68 for each one of these. Out of 476 randomly selected phone calls, if we're assuming all of the days of the week have the same probability of getting a call, then we expect about 68 calls for each of these categories. Part B, what is the correct statistical test to use? This is going to be a goodness of fit test. How do I know it's a goodness of fit test? Well, we have expected and observed count, so this must be a goodness of fit test. In part C, what is the null and alternative hypothesis? The null hypothesis is the statement of no difference. So let's look at these options and figure out what is the statement of no difference. And that would be the first option. The distribution of phone calls is uniform over the days of the week, so there is no preference. The distribution would be uniform because there is no preference, and that's our null hypothesis. For our alternative hypothesis, H1, we have to take the complement of the null hypothesis. So what's the opposite of the null hypothesis? And that would be the second option here. The distribution of phone calls is not uniform over the days of the week. So there is a preference. Maybe people prefer to call on a certain day of the week. Part D, we're looking for the degrees of freedom. The degrees of freedom is equal to the number of groups minus 1. So in this case, we know the number of groups is 7. We have 7 days of the week. So we're going to take 7 minus 1, and that's going to give us a degree of freedom of 6. For part E and F, we're looking for the test statistic and the p-value. So let's go on to our calculator for that question. We are on the goodness of fit calculator. I have entered the observed counts, and the expected counts should all be 68. Let's click calculate, and we have our chi-squared statistic is 14.529, and our p-value is 0.024. So let's jot down these numbers, chi-squared and our p-value. In part E, let's state our test statistic. Our test statistic is 14.529, and our p-value is 0.0243. The p-value is less than alpha since 0.0243 is less than 0.05, the level of significance. We do reject the null hypothesis. There is enough evidence to conclude our alternative hypothesis. Recall the alternative hypothesis. There is not a uniform distribution for the phone calls and days of the week. Question 4. A report just came out that stated 22.4% of all Americans say that vanilla is their favorite ice cream, 20% say that chocolate is their favorite ice cream, 8% favor butter pecan, 9.9% favor strawberry, and the rest have other favorites. An ice cream shop owner thinks that her customers are not like the rest of America. The table below shows the results of 800 of her patrons' ice cream selections. What can be concluded at the alpha equals 0.0
or 5 significance level. Let's complete the table by filling in the expected frequencies. We'll use the formula expected frequency is equal to n times p. We know n is the sample size, and that's 800. 800 people were selected for this study. So for the first row, we'll take 800 and multiply by the probability. We know the probability that favor vanilla is 22.4%, so we'll use 0.224. 800 times 0.224 is 179.2. Now in the directions, we want to round to the nearest whole number, so we should round this to 179. For chocolate, we'll take 800 and multiply it by 20%. 20% is 0.20. 800 times 0.20 is 160. So we expect 20% of those patrons to prefer chocolate, and that's 160. 160 out of 800 will prefer chocolate. Or should I say, are expected to prefer chocolate. For butter pecan, we'll take 800 and multiply by 8%, or 0.08, and that gives us 64. We expect 64 out of 800 to prefer butter pecan. For strawberry, we'll take 800 and multiply by 9.9%, or 0.099. That gives us 79.2, which we're going to round to 79. To find the percentage that prefer other, we'll have to add 22.4% plus 20% plus 8% plus 9.9%. This is equal to 60.3%. So this is the makeup of those that prefer vanilla, chocolate, butter pecan, and strawberry. So the other would be the rest. This gives me 39.7%. So I know 800 times 0.397 is the expected frequency for other flavors. We get this is equal to 317.6, then that rounds to 318. So we expect about 318 out of 800 to prefer other flavors. Part B, what is the correct statistical test to use? This is again another goodness of fit test. It's a goodness of fit test because we have observed frequencies and expected frequencies. This is the only hypothesis test with frequencies in it. Part C, what are the null and alternative hypotheses? Let's take a moment to figure out those. For the null hypothesis, that's the statement of no difference. So we're going to say the distribution of favorite ice cream for customers at her shop is the same as it is for the Americans in general. For the alternative hypothesis, it would be the complement of the null hypothesis. The complement would be, for the alternative hypothesis, we have the distribution of favorite ice cream for customers at our shop is not the same as it is for Americans in general. For part D, we're looking for the degrees of freedom. The degrees of freedom for a goodness of fit test is the number of groups minus 1. And if we look back at our problem, we have 1, 2, 3, 4, 5 groups. 5 groups minus 1 gives us 4. So the degrees of freedom is 4. For part E and F, we'll have to go to our statistics calculator for those. To do this on the computer, go to the goodness of fit calculator and enter the observed counts. And also enter the expected counts. Make sure you put a comma in between each of your entries. and then select calculate, and you should get your chi-squared statistic, which is 8.206, and here's our p-value, 0.0843. Let's make sure we jot down these values so we can finish our conclusion. From our calculator, we have the chi-squared statistic is 8.206, and also from our calculator, our p-value is 0.0843. Now we could come up with our conclusion. We'll ask, is the p-value less than alpha? The p-value is greater than alpha. 0.08 is greater than alpha. It is not less than alpha. So we do not reject the null hypothesis. We do not reject the null hypothesis. There is not enough evidence to conclude, and our conclusion is always in terms of HA. There is not enough evidence to conclude the distribution of favorite ice cream at this shop is different than Americans in general.